Hello everyone, welcome again in Eng-Man YouTube channel. So we will start another series of PVTP software, and it's going to be about retrograde condensate. In previous series, we have completed or we have tried to learn about compositional oil modeling. Now we will learn about compositional condensate modeling, and it's going to be retrograde condensate. All right, and many people say that modeling condensate is, more challenging than modeling oil. And I hope we can learn many things here in this series. Okay, so this video is going to be about introduction. So first, I'm going to show you the calculation options for our exercise. So preferences, the calculation options button. We will use Peng-Robinson for our fluid model, equation of state model, oil density method as usual, standing cuts, and we can leave other as per default. Okay, and then I prepare my sample here. So PVT sample initial like this. You can also double click to add another sample. Double click on the characterization wizard. Okay, but I'm going to delete it. Okay, so I double click on this. So sample type, it's downhole sample, reference conditions 1 atmosphere with reference temperature of 60 degrees Fahrenheit. And this is the reservoir conditions. You populate this cell with data, reservoir temperature 241 Fahrenheit. It's deep reservoir with reservoir depth of 13,000 feet. And this is the reservoir pressure, quite high and quite hot. And then the select components, as usual, I include C1, C2, C3, but I only use the normal butane and normal pentane. For the next component, I use hexane. We use hexane here as our fluid. And then the non-hydrocarbon, nitrogen and carbon dioxide. Okay. And then pseudo component 1. So the total selected components is 9. And enter composition here. If you want to follow me, you can get this data. You can look at this data and populate your PVTP with these values, with this data. And our pseudo component here, C7 plus, the molecular weight is 205. Okay, so you put this reservoir fluid mole percent and the molecular weight. Yeah. But for the pseudo component, you need to manually populate this with this value 205. Whereas for the pure component N2 down to 66, the molecular weight will be, imputed automatically by PVTP. And then for the composition input, of course, enter total stream composition, input as mole in my case, and percent for input type. And then enter lab data. This is very, very, very important. So we have 4 experiments. The first one is saturation pressure. This is the temperature and the saturation pressure in PSIG. Of course, you can import from PVT report, but in this case, I already have this prepared, populated with the data. And then the separator test, we have 2 stages. The first stage, the temperature, and then the pressure. I have the GOR. And for the second stage here, at atmospheric pressure, and then the temperature 60 degrees Fahrenheit, we get the GOR. And I also know the stock tank oil density. So the second stage is the stock tank. Usually it's the stock tank. Okay. And constant volume depletion, because we have condensate here. So usually we perform CVD. The temperature, pressure, and also liquid dropout. But we also have Z factor, deviation factor for gas phase. In this case, it is written as vapor phase. Okay. And lastly, constant composition expansion. We have temperature, constant temperature, and pressure, liquid dropout. Liquid dropout at saturation pressure volume, the relative volume, and also the Z factor. Okay. In for pressure above the bubble point, above the saturation pressure. Okay. And lastly, mass balance calculator. At this point, it would normally be advised to perform a mass balance calculation to assess whether the measured fluid properties are actually consistent. But in this particular case, however, there is not enough data to do this check, so we can leave it as it is. We can skip it. Okay, so click on this button, okay, and then you can save. And I'm going to stop it here. In the next video, we are going to define the pseudo components. Okay, so maybe this series is going to be quite long, maybe longer than, compositional oil modeling, but hopefully we can learn many things from this exercise. Okay, so see you in the next video. Thank you.